Hello, my name is John Ryan, and this is COM 361 Introduction to Robotics Project 1. First, I'll start with part 1, which was to imagine a robot has a 2D grid, and they need to not hit any obstacles, which is a black node, and they need to find the shortest path using Grassfire algorithm from the start node, which is green, to the red node. So I manually wrote in the wavefront, where 0 is the end node, and then you just move adjacently, vertically, and horizontally, kind of like a wave, and you increase by 1. And as long as you go from the start node and make sure you're always decreasing by 1, you will always find the shortest path. It's guaranteed. So there's actually two shortest paths. One where you go right to 12 and then 11 by going down, or you go right an extra time, then go down, and then just follow the same path here. It'll always be the shortest path. This is my manual solution to part 1. Now part 2, so I had to write a program. I chose to do it in Python, which automatically generates a search map for the robot and then finds the shortest path using the Grassfire algorithm. Here's my code. So I'm going to quickly just go through the functions. So I imported the deck so I can make the breadth for search, and then tkinter for the GUI. Let's generate grid. It just like a double for loop. So it just basically makes a 0 for each node in the rows and columns, and then place obstacles. In main, it gets the percent from the user, and then it takes that percent and multiplies it by the total number of nodes, and then as long as the amount of obstacles is less than that, it'll just keep making another one. It ignores the start and goal, and if it does the one that it's already done, it'll just keep doing it until it eventually hits the number that it's required. Grassfire, just the breadth first search. Basically, it's going in all those directions and increasing by 1. And then the extract path, this goes through it, making sure it's decreasing by 1, and then it always finds the shortest path, and it saves it. Print grid, basically start is an S, goal is a G, star is the path, and then X is an obstacle. A dot is everything else. And then this is the GUI with tkinter. Same thing, so a constant 30 pixels for each node, and then it changes the color of the node depending on what it is. So start is green, goal is red, yellow for the path, black for an obstruction, and then wait for everything else. And then there's a bunch of input validation in main. Basically, there's a couple requirements. So first of all, the has to be at least 8 for both the rows and columns. And for the minimum goal placement, the row had to be greater than half of the total. So if there was 10, it had to be greater than 5. And then for the columns, it had to be greater than 2/3. And there was an example, if it's like 10, it would end up being like 6.6 and all that. So it ceilings it, and then it randomly selects from that minimum value calculated there, and then to the input value. And then, yeah, that's basically the gist of it. So I'll demo it now. So first, it asks for the user to input 2 integers separated by space for the rows and columns. So we'll do 20 by 22, and then it wants the start column. We'll just do the top left, and then it wants the percent. I'll do the maximum 20. So it prints it to the terminal. You can see the obstacles with X's and everything. Then also it has the GUI version with tkinter. Oops. So that's pretty cool. And then if I close it, it'll also continue. It generates the path, puts it in the terminal. You can see with the stars, and then also tells you the shortest path length, and then it also says it in the title for this one as well. So yeah, that's it. Thank you for watching.